This thing on, see if it'll run. I went ahead and threw a disconnect power on, so we'll kind of fiddle around with thermostat. Let's just to show you how things work. I'm gonna flip the fan switch to on, and so my green light came on. Now I'm gonna set the thermostat to cool, but I've got the set point way above room temperature, so that when I actually set the thermostat to cool, the only thing you're gonna see is the reversing valve light up. Now if we back off on the or back down on our set point to get it to where it'll call for cool, then the contactor is going to pull in and our condenser and compressor lights come on. Of course our blower motor will come on again. So let me do that. So now the system's running in cool. Okay, let's go back off, and I'll pause the camera while the lights change, and we'll come back running heat. Okay, we're still in first stage heat. Now the little on-off switch I've got representing or simulating the defrost limit switch, it's in when the toggle's down, it's in the closed position. So if we come up here to our test pins on the defrost control and short across them, then if all this stuff does what it's supposed to do, then the board's going to initiate a defrost cycle. And of course what you're going to see happen then is the reversing valve will light back up. The blue light's going to go out because this relay is going to open up the circuit between these two wires, and it's going to effectively cut the condenser motor off. And then of course the red light will come back on. So let's do that. I get my shorten tool in here. This usually takes 6, 7, 8, 10 seconds. Now, okay. Reverser valves energized, condensing units, condenser fans de-energized, and if we give it just a few more seconds, we'll see the red light come on. Okay, now we're in the defrost cycle. If you're getting voltage up here at your source and say, well, we must have the okay voltage, then well, is the circuit closed all the way to the device? How many of these possible switches that could be open or closed? And then of course last but not least, if you got voltage and if the circuit continuity is good, then that just brings you down to the device. If it's getting voltage and not running, then there's something wrong with the component. Most often it's the low voltage wiring that causes the most problems and the most headaches, and are usually the most difficult to run down and actually troubleshoot and locate the problem. Okay, first situation, we're on the service call, the blower's running, condensing unit hasn't come on. We see the reversing valve light is energized, but the contactor just hadn't pulled in. Of course, it's always perfect, your first tendency to come over here and push in the contactor with your finger or something non-conductive is smarter, and see if it comes on. Then you know you don't have a high voltage problem. So at this point you got to get the meter out and start checking and see if you've got voltage coming in on the Y circuit. So we've attached one of our meter probes to the common terminal on the defrost board, or if there was a wire nut there, then you could take the wire nut loose and hook up to the wire. But like I say, try to get as close, as near to the air handler as you can with your common connection on the meter probe, so that you don't have to deal with opens in the common somewhere. And then our other meter probe is set up at the contactor. So because we already know we're not going to read any voltage, but anyhow, you got to go to the contactor and see if it's 24 volts there. There's always a possibility that the contactor is bad. So let's see if the meter will tell us that we don't have any voltage at the contactor. So at this point, we're actually measuring the voltage coming in from the thermostat. And we can see that now we're getting to 27 volts. So we know the problem is somewhere between the defrost board and the contactor coil. And either by looking at the wiring schematic or just visually tracing the wire with, maybe with using your hand and your eyes, you can quickly see that the yellow wire leaves the defrost control board, it goes down to a pressure switch, comes out of the pressure switch, and then goes over to the contactor coil. So aside from the possibility of the wire being broken somewhere in between there, the logical suspect in this case is going to be this high pressure switch. Alright, let's do another one with the same general situation. The blower's running, the condensing unit's not running, the reversing valve is energized, so we've already got a meter probe down here at the front side or the hot side of the contactor, and we'll see that the voltage is 27 this time, so this is a little bit different than it had before. Now you may think, well, some folks might think at this point, well, obviously the contactor's messed up, but you know, don't be too hasty. Let's get back down there and read on the back side of the contactor coil and see what we get. So moving the probe over to the back side of the contactor coil, if in fact we read 0 voltage here, then we can say, yeah, there's something wrong with the contactor coil, it's opened up. But as we're going to see, the meter says that we read 27 volts again. So obviously we've got a problem somewhere else. Now we can check with this one-piece thermostat, because if the thermostat's telling the Y circuit to energize, then we should be able to read 24 volts on our wire terminal. With a two-piece stat, what you're going to have to do is take the first cover, actually remove the thermostat wiring, and I'll create some shorts, and we'll see how you might go about eliminating the ones that are not bad and finding the one that is. The only two ways I know to find a short circuit is either use your multimeter and the ohm scale and run some resistance checks through the circuits. Either you can do it up at the thermostat, or you can do it at the air handler where you got some connections to check to. And then the other way is, which is usually turns out to be faster, is just replace everything, put a fuse in the circuit or in the system, and then just energize one circuit at a time. Like go to the thermostat and just energize the blower and see if the fuse stays okay. Then you can energize the contactor and see if the fuse blows. Then you can energize the reversing valve circuit by putting the system in cool. And then from the previous time when we knew everything was normal, then we've got three possible circuits that have got shorts in them. And as I said, there's only one I know that has a short in it. So at this point, you've reached the conclusion that there is a short circuit somewhere in the system, which is what caused the fuse to blow or the transformer to burn up. But now you've got to go back and start eliminating possibilities. And in order to do that, you've got to start disconnecting, you've got to start breaking the circuit somewhere. So at the failure to begin with. So with this crash method, if you're at the air handler, you could just take a jumper and jump from R to the 4 circuits that we use, which is second stage heat, blower, contactor, and reversing valve. Or you can come up to the thermostat and just turn the switches and make set points such that you just get one circuit energized at a time. Okay, I'll run the thermostat and you watch the lights. First of all, we're going to flip the fan switch to on, and the blower came on, so we know that circuit's okay. Already eliminated all those. Now I'm going to call for second stage heat, and you watch the fuse. I don't know if you can see it or not. So, looks like something wrong in our second stage heat circuit. One of my early blunders in troubleshooting was with a package heat pump that had gone out during the heating season. The lady told me that during the night she heard the heat pump make, in her words, an awful racket, and then it just died. And when I showed up, I found, after a little bit of checking, I found that the transformer burned out. And all I did at that time was just replace the transformer. I didn't even know about, well, I knew something about fuses, but I didn't have enough sense to put one in the circuit. Of course, the next morning she called me back. Same thing had happened during the night. You know, it made an awful racket and died. Well, when I went back the next morning,